Optics 2 is refraction. Okay, now before we look at refraction, consider this. When light passes through a more optically dense material, for example, if light is traveling in air and it goes through a glass block, what happens to light when it goes through a glass block? Well, the answer is it slows down, and because it slows down, its wavelength gets smaller. You can imagine this as rows of soldiers. If there were rows of soldiers marching along and they went into a muddy field, then they would slow down and the rows would get closer to each other. And then when they come out of the muddy field, the distance between them would increase again and they would speed up. This diagram shows plane wavefronts. You can see them from above, and maybe these are the crests of the wave and these plane wavefronts moving along. Now, this is if the light enters normally, normal as in perpendicular. If the light enters normally, then it just carries on in the same direction. If the light enters at an angle, then what happens is it changes direction. Now, I've done two diagrams here. I've done the wavefront diagram and I've done a ray diagram, and we'll be using both of these diagrams. Why does it change direction? Well, it changes direction because it slows down, and then when it leaves the glass block, it speeds up again. If you like, our rows of soldiers, the ones near the bottom, they will slow down first, and so the direction that they're moving in, or that the rows are moving in, will change, and then they will speed up first. So basically, you won't be asked why it changes direction, but it's because it slows down. See on the bottom diagram, I've marked the normal, and it's usually done as a dotted line. Snell's law, N equals C over V equals sine I over sine R. N is called the refractive index of the glass, N, and it's equal to the speed of light in air divided by the speed of light in the glass, or the denser medium. And it's also equal to, thanks to Snell's law, sine I over sine R, where little I is the angle of incidence and little r is the angle of refraction. This is very GCSE. A little trick, it basically, if you're not sure if it's an angle of incidence or an angle of refraction, just remember that I is the bigger angle. There's a big angle and a small angle, and if sine I over sine R is going to be bigger than 1, then I has to be bigger than R. Okay, here's a question for you to have a go at. A ray of light refracts when it enters water as shown. Use the angles given to calculate the refractive index of water, the speed of light in water, and then what would the angle of refraction be for an angle of incidence of 35 degrees. Pause the video, have a go at it. I'll show you the answer in a couple of seconds. And the answer is that. Last diagram in this video is just showing you what happens when white light goes through a triangular prism. White light, as in, for example, the light that we get from the sun or from a bulb, is white light. It contains all of the colors, Roy G. Biv, and you'll see dispersion. And this happens because the refractive index for the different colors is different. Okay, so some of the light slows down more than others. I remember blue bends best, or if you like, the blue end of the spectrum bends more than the red end. And this effect is called dispersion. And this is how Isaac Newton showed that white light is a mixture of colors.